Hello, fellow seekers. Here is the question. The ancient Greeks proposed a thought experiment suggesting that if you shoot an arrow at a target, the arrow should, logically, never reach its destination. This is because it would first have to travel half the distance to the target, then half the remaining distance, then half of that remaining distance, and so on, infinitely. The experiment assumes that any distance can be divided in half endlessly, meaning that the arrow would never actually arrive at the target. However, if we consider that the arrow itself could also be infinite in a similar way, just as the space between it and the target is infinitely divisible, one might conclude that every object and every measurable distance is also infinite by the same logic. In this view, the arrow, the space it travels through, the target, and even the room containing them all possess infinite qualities, as each is infinitely divisible. Extending this idea further, every atom within the arrow could also be considered infinite. If the universe is both infinitely expansive in all directions and infinitely divisible within any chosen length, then we encounter infinities within infinities, similar to the endless sets of odd, even, and prime numbers within the infinite set of numbers. But does the concept of the arrow being infinite in this way resolve the original paradox? Does acknowledging these infinite qualities help explain how the arrow could still reach the target? Let's discuss. The thought experiment in question, a paradox often attributed to Zeno of Elea, brings to light some fascinating implications about space, time, and the nature of infinity. At its core, it poses a dilemma in which the logical division of distance into infinite parts seems to imply that motion should be impossible, as completing an infinite series of steps within a finite time appears paradoxical. By exploring this paradox in depth and examining novel arguments and counter-arguments, we can approach a deeper understanding of what it means for the arrow, the space it travels, and the universe itself to be infinite. 1. The nature of divisibility and infinite series. The essence of Zeno's paradox is rooted in the notion that any measurable distance can be divided infinitely. If the arrow must first cover half the distance, then half of what remains, and so forth, this seems to create an unending series of tasks the arrow must complete. However, mathematically, we know that an infinite series of diminishing distances can sum to a finite value. For example, in the series 1/2 plus 1/4 plus 1/8 plus 1/16 and so on, the sum approaches but never exceeds 1. This is known as a convergent series, and it provides a mathematical resolution to the paradox. The infinite sequence of steps sums to the finite distance between the arrow and the target. Counter-argument. Although this mathematical explanation resolves the paradox theoretically, it doesn't address the conceptual discomfort about motion through infinite divisions. If each division represents a real, physical task, how does the arrow move through them? The paradox seems to question not only whether the series converges, but whether a physical entity can ever traverse an infinite set of steps, even if their sum is finite. 2. Infinitely divisible space and physical reality. The argument that space is infinitely divisible raises profound questions about the nature of reality. If the arrow and the space it moves through can be divided infinitely, this would imply that there is no fundamental smallest unit of space or matter. This conflicts with theories in modern physics, which suggest there may be indivisible building blocks of reality, such as the Planck length, beyond which the concept of space itself may lose meaning. Counter-argument. However, if we adopt the classical notion of infinitely divisible space, we encounter a strange implication. Every point along the arrow's path would contain an infinite number of potential divisions. This would mean that for every infinitesimally small moment in time, there is an infinite amount of spatial data associated with the arrow's position, effectively embedding infinity within every fraction of a second of motion. Resolution through quantum mechanics. Quantum mechanics suggests that on extremely small scales, particles don't travel in smooth, continuous paths, but rather in discrete jumps, quantum leaps, which could offer a physical basis for bypassing the paradox. If movement on an atomic scale isn't truly continuous, the infinite divisibility of space may not reflect physical reality. The arrow, then, does not occupy an infinity of positions along its path, but rather discrete quantum states, sidestepping the issue of infinite divisibility in a finite traversal. 3. The arrow as an infinite object. The idea that the arrow itself could be infinite mirrors the concept of infinite divisibility, but introduces a different perspective. If both the arrow and its trajectory possess infinite qualities, perhaps the paradox is a misunderstanding of how infinity functions in physical terms. Argument for the arrow's infinity. Solving the paradox. If we consider that the arrow and all objects are infinite in structure, e.g., possessing an infinite number of possible divisions or substructures, then the concept of moving through infinity becomes part of the arrow's nature. Instead of thinking of motion as traversing a series of finite segments, we might see it as the arrow's infinite nature, unfolding along an infinite trajectory. In this framework, both the arrow and its path are expressions of the same infinite reality, making the paradox an illusion rooted in a mistaken assumption about the nature of physical objects. Counter-argument. However, defining the arrow as infinite in this way might simply shift the paradox rather than solve it. If everything is infinitely divisible, we still face the original problem of how an object moves through an infinite series of divisions. Declaring the arrow infinite does not necessarily explain how its motion bypasses the infinite steps it theoretically should encounter. 4. Infinities within infinities. Does it complicate or resolve? The analogy with infinite sets of numbers, like odd even and prime numbers, introduces an intriguing dimension that there can be different sizes or types of infinity. Perhaps Zeno's paradox arises because it conflates different forms of infinity. The infinity associated with the arrow's distance to the target may differ fundamentally from the kind of infinity associated with its motion. Argument for multiple infinities resolving the paradox. If we consider that spatial infinities, like the distance between the arrow and the target, are conceptually distinct from the infinity of actions required to traverse that distance, we might conclude that these infinities can interact without contradiction. Just as there are different cardinalities in mathematical infinities, perhaps the infinity of physical divisions is not directly comparable to the infinity of the arrow's movement through them. Counter-argument. Introducing different types of infinity can be seen as an abstract solution that doesn't fully address the physical basis of the paradox. We are left with a need to understand how these infinities manifest in the real world. If they're purely mathematical concepts, they may not provide a satisfying answer to a physical question. 5. Temporal infinity and the role of time in resolving the paradox. Time plays a central role in Zeno's paradox, as it implies that an infinite number of spatial divisions would also require an infinite amount of time to traverse. But if time, like space, is infinitely divisible, then the arrow's motion can be understood as progressing through infinite time intervals, each becoming progressively shorter. Argument that temporal infinity resolves the paradox. In this view, the arrow never truly encounters an endless sequence of tasks within finite time. Instead, each fraction of distance it traverses corresponds to an equally diminishing fraction of time. Thus, just as the infinite spatial series converges to a finite length, the infinite series of time intervals converges to a finite duration, allowing the arrow to reach its target. Counter-argument. This reasoning, though mathematically sound, doesn't entirely answer the philosophical challenge. The notion of infinite temporal divisions raises questions about the nature of time itself. Is time a smooth continuum, or does it exist in discrete moments that prevent the paradox from arising? If time has a fundamental granularity, then the paradox might be sidestepped altogether, as each moment represents a discrete, non-divisible instant. 6. Philosophical implications. Does the paradox reflect reality or human cognition? Finally, one could argue that the paradox may not reflect a physical truth about the universe, but rather a limitation in human cognition. The paradox arises from our tendency to view space and time as infinitely divisible abstractions, a concept that may not correspond to the actual structure of reality. Argument for the paradox as a cognitive construct. If the paradox is a byproduct of how humans conceptualize motion, then its resolution might lie in recognizing that reality doesn't adhere to our mental models of infinite division. Physical objects, trajectories, and even time might operate within frameworks that evade infinite division, rendering the paradox moot outside of our conceptual boundaries. Counter-argument. Dismissing the paradox as purely cognitive may seem unsatisfactory, as it leaves unanswered questions about the real nature of motion. If reality doesn't conform to infinite divisibility, what is the actual structure of space and time? This line of inquiry pushes us toward exploring deeper theories, such as those in quantum mechanics and relativity, where the nature of motion, space, and time diverges significantly from classical assumptions. Conclusion. Does infinity resolve the paradox? Ultimately, viewing the arrow, space, and time as infinite brings us closer to addressing Zeno's paradox, but it does not provide a complete resolution on its own. The paradox challenges us to reconsider our foundational concepts of divisibility, motion, and infinity. Modern mathematics and physics offer frameworks that can address the paradox, such as convergent series in math and quantum discreteness in physics. Yet the question remains, is infinity a real property of the physical world or a construct of human thought? In this sense, Zeno's paradox endures not only as a mathematical or physical puzzle, but as a philosophical inquiry into the nature of reality itself. Whether the concept of infinity solves the paradox depends on whether infinity is something intrinsic to the universe or merely a tool for navigating its mysteries. Thank you for spending time with me in the great abyss of knowledge that we call home.